So we have seen a couple of examples using the DS directive, which is define storage, and the EQU directive. Now, we said that the DS directive just defined a set of memory locations or an individual memory location, and it gave the memory locations a label. So for example, you could have DS1, in this example here you can see DS1 array 10. So what it does is it sets aside 10 consecutive memory locations, and it calls that set of memory locations array. Now, it doesn't put anything in those memory locations. Those memory locations are made available for the program, and those become filled up as part of the code through the rest of the program. Now, we also mentioned about the EQU. So the EQU directive, in this instance here, we've got an example, EQU 6th is the number here. So this here is the binary number for 5. Now, again, this doesn't put any values into memory. This is available really just within the assembler. So it's saying that the label 6th has actually got a number 5 associated with it. So everywhere in a piece of code where you see the label 6th, it will replace it with the number 5. Okay, so it doesn't put anything physically in memory. Okay, now the last directive that we're going to look at, and we will look at a couple of examples using it, but I thought I would show you in this program here, because you can see and you can compare it to the other directives. Now, the other one is the DC directive. That means define constant. So in this instance here, you could look at this define constant 2, and it's called second, and it's got a value of 20. Now this is the difference between the DS and the DC. The DS sets aside the memory locations, but we don't put anything in it. Whereas the DC will set aside a memory location, but we will put a value in it. Okay, and then we only do it just one at a time. Okay, so we can only put, with the DC, we can put one value in one memory location. If we want to put a value in another memory location, we need another DC. Okay, and we need to continue putting the DC values. So this is going to put 20 in this memory location second. So those are our three directives: DS, DC, and EQU. Now let's have a little look at these here, and we can see the actual assembled code, which is over to the right. So the start address here is 8020. Now 8020 in integer is actually 32,800. So the very first one here, it really just says that we're going to put 15 into something called first. Now first is just going to be the memory location 32,800. So we have the data #15 32,800. Now the next line here says DS1 define storage, and it's called array, and array has got 10 memory addresses associated with it. So we're setting aside the next 10 memory locations. So the next 10 memory locations are from 32,801 to 32,811. Okay, so we've now got another 10 memory locations set aside. We haven't put anything in it, but we've got those set aside. Now the next one that comes along is going to be again a define the constant, and it's second, and it's a value 20. So we're going to put 20 into the memory location, and it's the next memory location after this set of 10 in the array. So it's going to be the location 32811. Now the next one here, we've got DC, and we're able to define not only literal terms, we can define text as well. So we can define this as hello, and you can see it's got the single quotes. So if you want to define characters, we put them in single quotes like this. Now what this does is, it goes in here, it finds the ASCII value for H, E, L, L and O, and it places them in the next set of memory locations. So in this instance, the next memory location is going to be 32812, 3, 4, 5 and 6. So these values here, hash 104, 101 and the 108, 108 and 111, these are the ASCII values for the H, E, L, L and O. So it goes and it places these into the memory. And then there's another one here that says DS2, so it sets aside another array and it's got another 10 values. And then we define a constant fourth, which is a value H. So if we head in here, you'll see that we're going to have the next value after this 17 here is going to be the position 28, because it's 10 values after the 17. Okay, so and we put in the value for the ASCII for H, which is 104. Now finally in this one here, you can see that we've got the EQU directive. Now you see the EQU doesn't appear anywhere here, because this directive is only used within the assembly language. We're saying that anywhere you find the label 6th, you replace it via this number here. But we don't do anything in memory, and it doesn't set aside any memory locations. It's really just for us to work with in the assembler. So that's all for this video. I'll get you on the next video. Goodbye.